The Strait of Gibraltar, a 14-kilometer gauntlet where the Atlantic's raw power meets the ancient Mediterranean pulse. But today, this gateway is the site of a $750 billion architectural defiance against nature.
Experts are warning that the rising sea levels could see these cliffs erode completely within the next decade, threatening the historic lighthouse just south of here.
The mission: build a tidal wall so massive it dictates the sea level of an entire continent and saves Venice. This is Blueprint Flow. We are dissecting the process of installing the most powerful energy harvesters ever conceived by man. The primary challenge isn't just depth. It is the kinetic fury of currents moving at 5 meters per every second. Every steel joint and turbine blade must survive a crush depth pressure equivalent to a main battle tank's total weight. We begin at 300 meters down. The seabed must be leveled with sub-millimeter precision using diamond-tipped boring heads. 50 million cubic meters of specialized hydroconcrete are being pumped into the abyss to create an immovable foundation. Behold the turbine module, a 100,000-ton titanium steel beast designed to spin for a century without maintenance. Navigating these behemoths through the planet's busiest shipping lane requires a ballet of heavy-lift ships and naval escorts. Our automated fleet of TBMs works tirelessly in the dark, carving grooves into the limestone with surgical engineering accuracy. Failure is not an option here. A microscopic crack in the turbine housing would lead to a catastrophic underwater implosion. We are pushing the boundaries of material science, utilizing graphene-reinforced alloys that resist the relentless corrosion of salt water. This is the dawn of the Gibraltar Gate, the day humanity finally learns to harness the heartbeat of the world. The blueprint demands a structure capable of generating 90 gigawatts of power, enough to fuel half of the European continent. This requires the installation of 1,000 individual turbine units, each acting as a massive underwater power station. Engineers are now deploying the gravity-based system, massive hollow concrete rafts that will be flooded to sink into place. The descent must be controlled by high-tension winches, keeping the structure level against the unpredictable cross-currents of the deep. Once on the seabed, the base is locked using 4-meter-wide steel piles driven 50 meters deep into the solid rock crust. Watch the precision of the hydraulic hammers. Each strike delivers 6,000 kilojoules of energy to shatter the limestone barrier. There is no room for error. If the base tilts by even half a degree, the turbine blades will eventually shear off. Back at the surface, the assembly of the turbine hub begins. This is the rotating heart of the entire Gibraltar Gate. The bearings are lubricated with a specialized synthetic gel that can withstand the immense salt concentration of the Mediterranean. Technicians use ultrasonic sensors to detect microscopic air bubbles within the metal casting that could expand under deep-sea pressure. The 3 blades, made of carbon fiber weave, are being bolted to the hub using 300mm diameter titanium fasteners. Each blade is 80 meters long, designed with an aero-hydrodynamic profile to maximize torque even in slow-moving water layers. The internal generator utilizes rare earth magnets cooled by the surrounding seawater to maintain peak electrical conversion efficiency. A complex network of high-voltage cables is now being prepared for the most dangerous underwater connection in history. Every cable is double-shielded against electromagnetic interference and the crushing weight of the sedimentary layers above them. As the foundations settle, we initiate the deep link phase, connecting the submerged turbines to the continental power grid. A fleet of autonomous swarm bots is deployed to scan every inch of the structural hull for thermal anomalies or stress fractures. These bots operate with a collective intelligence, mapping the shifting sands of the strait to prevent turbine burial. Engineers monitor the data from a floating command center, where every heartbeat of the machine is tracked in real time. The pressure at this depth is relentless, pushing against the turbine seals with the weight of 1,000 atmospheres. To counter this, a nitrogen-pressurized internal chamber maintains an equilibrium, protecting the sensitive electronic brain of the unit. Look at the junction boxes. They are encased in transparent ceramic glass, allowing for visual inspection without breaking the vacuum seal. The installation of the secondary debris filters is now underway to protect the blades from shipwreckage or marine life. These filters are made of high-tensile Kevlar mesh, capable of stopping a drifting shipping container without losing its shape. Above water, the construction of the maintenance elevators begins. Giant pressurized tubes that travel directly to the sea floor. This vertical logistics system allows for the rapid transport of heavy tools and replacement parts in any weather condition. The docking ports use electromagnetic coupling, ensuring a watertight seal even when the surrounding currents are at peak velocity. Specialized divers, breathing a helium-oxygen mix, perform the final manual inspections on the primary torque sensors. They work in total darkness, guided only by the powerful LED arrays mounted on their titanium alloy exoskeletons. Every bolt tightened here is a testament to human endurance and our refusal to be intimidated by the deep ocean. The energy captured by the turbines is converted into ultra-high voltage direct current to minimize transmission losses across the sea. Massive undersea substations, encased in reinforced concrete shells, act as the central nervous system for the entire energy grid. Within these shells, sulfur hexafluoride gas is used as an insulator for the massive switchgear to prevent electrical arcing. Automation is the key. AI-driven software balances the load in real time, reacting to the moon's gravitational pull on the tides. We are now witnessing the first full-scale rotation test of the central turbine cluster, a moment of extreme technical tension. The torque generated is so immense it could power a medium-sized city with just a single rotation of the primary shaft. Laser interferometers are deployed to monitor the structural deflection of the dam's main spine under this massive kinetic load. If the vibration frequency matches the resonant frequency of the bedrock, the entire structure could shatter like glass. To prevent this, active mass dampers, similar to those in skyscrapers, are installed within the pylon cores to neutralize tremors. The cooling system for the transformers utilizes a passive heat exchange with the cold deep-sea currents, maximizing efficiency. Notice the specialized anti-fouling coating on the blades. It uses a biomimetic texture inspired by shark skin to repel barnacles. Without this, the added weight of marine growth would reduce the turbine's efficiency by 30% within a single year. The underwater power cables are now being buried 2 meters under the seabed to protect them from dragging anchors of illegal vessels. A specialized jet plow ship uses high-pressure water streams to carve the trench while simultaneously laying the cable in one pass. Every kilometer of cable is fitted with fiber optic sensors that can detect a breach or a temperature spike within milliseconds. We have reached the critical spine integration phase, where the individual turbine blocks are locked into the main dam wall. This central spine acts as a massive bridge, spanning the deep water channel and stabilizing the entire energy extraction field.
We are standing high above the main assembly floor, where these colossal gears regulate the flow of power to the entire facility.
Each interlocking block is held in place by gravity and specialized thermal expansion joints that adapt to the changing water temperatures. The logistical precision required is staggering. A fleet of 20 heavy lift vessels is operating in a synchronized, GPS-guided formation. Look at the sheer size of the anchor pylons. They are wider than a soccer field and descend deep into the Earth's mantle. The pressure-resistant hulls of these pylons are filled with heavy magnetite slurry to provide the necessary downward ballast. Engineers are now using liquid nitrogen to shrink the primary connecting pins before inserting them into the main structural hinge. As the pins warm up, they expand to create a permanent, interference-fit bond that no mechanical force can ever break. A specialized group of underwater welders uses plasma arc torches to fuse the outer protective plating against the ocean's salt. They must work within habitats, dry, pressurized bubbles that allow for high-quality welding far below the surface of the sea. The internal tunnels of the dam are now being pressurized, allowing for the first team of resident maintenance engineers to move in. These tunnels are equipped with magnetic levitation tracks, ensuring fast movement of personnel across the 14-kilometer span. Every oxygen sensor and fire suppression system is tested every hour. In this environment, safety is the only currency that matters. The roar of the Atlantic is audible through the thick steel walls, a constant reminder of the power we are trying to tame. As the spine is finalized, we deploy the AI-driven debris shields, a series of automated barriers to deflect drifting maritime waste. These shields use acoustic pulses to steer marine life away from the turbine intakes without causing biological harm to the ecosystem. Every shield is monitored by an array of high-definition sonar sensors, mapping the underwater traffic in real time for maximum safety. The project now faces its ultimate test, the full-flow induction, where the gates are opened to the primary currents. Hydraulic rams, each capable of lifting a mountain, slowly retract the heavy sluice gates to expose the waiting turbine blades. The rush of water creates a roar that vibrates through the bedrock as millions of tons of seawater begin their forced passage. Within the generator housing, sensors detect the first rotation, a surge of electrical potential that travels through the grid. Specialized cooling circuits using liquid salt are activated to manage the intense thermal energy generated by the shear friction. The torque being managed here is equivalent to 10,000 jet engines, requiring the world's strongest carbon steel drive shafts. Technicians in the control room observe the harmonic frequency, ensuring that the dam doesn't enter a state of structural resonance. The sea level on the Mediterranean side begins its first controlled adjustment, a geopolitical shift that will save coastal cities. Floating sensor buoys across the strait transmit data back to the dam, measuring the change in salinity and water temperature. Any anomaly in the flow triggers an automatic pitch adjustment of the turbine blades to maintain a perfectly stable power output. We are now seeing the realization of a dream, a dam that doesn't just block water, but breathes with the rhythm of the tides. The Gibraltar Gate is no longer a construction site. It is a living, pulsing lung of the world's global energy infrastructure. With the turbines spinning at full capacity, the Gibraltar Gate must now manage its second primary function, maritime transit. Two massive navigation locks, each 300 meters long, allow giant container ships to bypass the tidal barriers safely. The locks use a triple redundant gate system, ensuring that the Mediterranean's water level remains perfectly isolated during the transit. Automated magnetic tugs pull the vessels through the locks with zero emission, guided by a central AI traffic controller. Watch the precision of the water leveling. 10,000 cubic meters of water are displaced every minute without creating a single wave. Below the shipping lanes, the dam's maintenance drones are constantly at work, scrubbing the hull to prevent micro-corrosion. These drones use induction charging docks built directly into the dam's structure, allowing for 24/7 autonomous operation. The sheer amount of data generated by the dam requires a dedicated underwater server farm, cooled by the surrounding abyss. This data hub processes millions of sensor inputs every second, predicting weather patterns and tidal shifts days in advance. In the event of a rogue wave or a seismic event, the dam can enter fortress mode in less than 60 seconds. Massive steel shutters slide into place, sealing the turbine intakes and locking the navigation gates against the incoming surge. The structural integrity is reinforced by an internal lattice of carbon nanotubes, making the wall virtually indestructible by nature. Every 6 months, a specialized crawler robot travels the entire length of the dam, X-raying the concrete for internal fatigue. Any microscopic void discovered is immediately injected with a self-healing polymer that bonds at a molecular level. We are looking at a masterpiece of engineering that bridges the gap between biological needs and industrial ambition. The final stage of the Gibraltar Gate is the activation of the Hyperlink Bridge, a high-speed transit artery atop the dam. This structure now physically unites Europe and Africa for the first time in 5 million years, changing global trade forever. The energy surplus is being channeled into massive hydrogen production plants, fueling a green revolution across 2 continents. Look at the stabilization of the Mediterranean ecosystem. The controlled salinity levels are reviving ancient coral reefs in the deep. The dam's artificial intelligence now shares its climate data with the world, acting as a global early warning system for sea level rise. Beyond power and transport, this project stands as a monument to human cooperation in the face of planetary-scale crises. The maintenance crews, who have spent years in the abyss, now see the first results of their silent, grueling labor. Engineers at the central hub perform the final synchronization, locking the dam into the global energy internet without a single glitch. The sheer scale of the Gibraltar Gate is visible from orbit, a thin, glowing line of hope etched across the dark ocean. Every megawatt generated here is a carbon-free victory, securing a future for generations we will never live to meet. We have successfully converted the destructive force of a changing climate into a controlled source of infinite prosperity. The blueprint flow process is now complete, from the first diamond-tipped drill to the final magnetic seal on the primary pylon. This is the legacy of Blueprint Flow, proving that with engineering and vision, we don't just survive the future. Hung IXYD-NGN. The Gibraltar Gate is open. The heartbeat of the ocean is now under the command of the architects of tomorrow. Blueprint Flow, engineering the impossible. Thank you for witnessing the birth of a new era. Project status, operational.